Hi folks, I'm going to take a look at an example of sketching the graph of a derivative function given the graph of the original function. All right, so here's an interesting function. It's not just something that looks like a polynomial. So let's see what happens when we try to sketch the graph. So reminder that when you're trying to determine information about the derivative, what you're looking at are the slopes of the tangents. Okay, you don't really care about the y values of the function themselves, but just the tangent at that point. All right, so let's take a look from negative infinity to this vertical asymptote. So there's no points in this area here where the slope of the tangent is 0, so the derivative is not going to have any x-intercepts here. So if we take a look at what the tangents are doing, well, I see that as I approach negative infinity, I see that the slopes of the tangents are positive, but getting flatter and flatter and flatter. They seem to be approaching 0. And then as I move to the right towards the asymptote, they're always positive, but getting steeper, 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 seeming to get infinitely steep. So that means that the derivative is going to look something like this. Now, I'm not going to worry about the actual values of the derivative, so I'll just draw something that looks reasonable. Okay, so we see here, again, as we approach negative infinity, the slopes of the tangents are approaching 0, and as we approach this vertical asymptote, the slopes of the tangents are getting steeper and steeper and steeper, and so the derivative is going to positive infinity. All right. So let's now look to the right of that vertical asymptote, and here I see that around this point, it looks like I've got a local minimum, and it looks like the slope of the tangent there is going to be equal to 0. So that means that the derivative function will have an x-intercept right around that point. All right. So let's take a look to the left of the 0 up to this vertical asymptote, and let's see what the slopes of the tangents are doing. Well, they're negative, and they're getting more and more negative, steeper and steeper and steeper as I move towards this vertical asymptote. All right, so that means that my derivative function should be going down to negative infinity here. Okay, because again, all negative slopes of the tangents and getting steeper and steeper as I move towards the vertical asymptote. Now, if I look towards to the right of this point here, I see that the derivatives are positive now. The slopes of the tangents are positive, and I see they're getting more and more positive. In fact, as I approach this cusp, it looks like the tangents are getting infinitely steep. You know, if I look only approaching from the left here, it looks as though at this point I'd have a vertical tangent. So what that's telling me is that the derivative function should have a vertical asymptote here, okay? Because as I approach this point, the slopes of the tangents are getting infinitely steep. Okay, so there's my vertical asymptote. But when I look to the right of this cusp, look at this again, only looking from the right. It does not look as though the tangents are getting infinitely steep here. Okay, first of all, I see that they're negative, but they seem to maybe approach a tangent that looks like this. Certainly not a tangent that looks vertical. Okay, so recall that the derivative can't exist but at that cusp. So I'm just going to pick some random negative number, and I'm going to make sure that I put a hole there, because the derivative can't actually exist at this point. But I see that it's approaching some negative slope as I approach from the right. Okay, and let's see what's happening. We see that it's getting less and less negative, okay, till about this point here, where the slopes of the tangents are still negative, but it's getting more and more negative. Okay, so it looks as though derivative is going to get less negative till about this point. Okay, and then once I reach this point, they're going to start getting more and more negative. So it should go down to negative infinity. All right, so let's just do a recap here of what we did. So when you don't have a point that's going to have a horizontal tangent, you need to observe what those tangents are doing. Here we saw that they were getting flatter as we approached negative infinity, so that means the derivative was approaching 0, and they were getting infinitely steeper as I approached this vertical asymptote, so the derivative was also approaching positive infinity because the slopes of the tangents are all positive. Here, I was able to use the fact that we had a horizontal tangent to draw an x-intercept. And then as I look to the left and right, I could see that the slopes of the tangents were going to be negative and getting steeper to the left and positive and getting steeper to the right till I reach this cusp. But on the other side of the cusp, it didn't look like the slopes were getting infinitely steeper. Okay, so we just picked some random negative number to represent what the slopes of the tangents were approaching. And we saw that as we went down, they got less negative, so less negative, and then past around this point, they started getting more negative and infinitely steeper. So that's why we brought it down to negative infinity. All right, that's it for this one.